we are going to dive into an interactive shiny app that predicts NYC taxi fares using machine learning. We'll explore how this app uses data, feature engineering, and a random forest model to provide fare predictions. So, let's get started. Coming to the introduction of this app is built in R with Shiny, a framework for creating interactive applications. So, it uses historical NYC taxi data to predict fare amounts based on the key trip features like distance, passenger counts, and pickup time. Our goal is to make fare predictions accessible and interactive for users, providing insights into NYC's taxi fare patterns. So, coming to the app layout, this app has two main sections: a sidebar to upload the data and trigger predictions, and a main panel displaying a histogram of predicted fares along with the key model metrics. So, this is how it works, giving the CSV file, clicking on the predict button, and yeah, we got the results over here. So, we'll walk through each part of this workflow, starting with the data upload and pre-processing. So, coming over there, once the data is loaded, this app performs essential pre-processing steps like converting data, date columns, creating new time-based features, and filtering trips with NYC boundaries. These steps ensure data quality and accuracy before moving into the modeling. So, coming to the feature engineering over here, we create columns such as pickup hour and day of the week, which help the model capture fare variations based on the time of the day or day of the week, like rush hour versus peak hours, etc. We then train a random forest model to predict fares using multiple decision trees. So, after predictions are made, we can view the results in this histogram. So, which shows the distribution of predicted fare amounts. This gives a quick look of a typical fare ranging from short trips to longer trips. To evaluate this model, we use R squared as a key metrics. R squared indicates how much of the fare variability is explained by the model. For our data over here, we achieved a high R square of 0.80, suggesting that the model effectively captures the patterns.
Apart from app development, let's talk about data visualization part. To understand NYC taxi demand, we developed several data visualizations, beginning with an interactive map highlighting high demand pickup locations. Using the leaflet package, we marked these areas with red markers and also included a legend for easy exploration. We then created density plots to visualize the frequency of pickups and drop offs across the city, with darker regions indicating a higher activity. This approach quickly reveals NYC's busiest zones. We then created we to explore demand over time. We plotted trip counts by hour, identifying peak periods like rush hours. And for a deeper spatial analysis, we applied DB scans clustering to the pickup data, pinpointing concentrated areas such as airports and business districts, and visualized these clusters on a scatter plot. Finally, we built an interactive map showing both pickup and drop off points with fare amounts labeled, providing a comprehensive view of taxi routes and demand distribution. Let's talk about the challenges that we faced while working on this project. First, managing the vast NYC taxi dataset, which includes over 12 million records, was a primary challenge. Processing this data in real time would be inefficient, so we had to subset the dataset to retain essential patterns while also significantly improving its performance. Second, integrating map based visualization posed another challenge. We used the leaflet package to create interactive maps and also applied DB scan clustering to highlight high demand locations like airports and popular tourist spots. Lastly, balancing model accuracy with app responsiveness required careful tuning. Increasing the number of trees in the random forest model improved accuracy, but also it slowed down the predictions. By fine tuning the model, we found an optimal setup that maintains both speed and prediction quality. In summary, this shiny app demonstrates how machine learning can predict taxi fares based on trip data with added geographic insights for practical application. Thanks for watching, and check the video description for resources and code links. Happy analyzing!